theory of plate tectonics. The following video is going to answer the questions: what is a theory? What is the theory of plate tectonics? What evidence exists to support the theory? And why do tectonic plates move? What is a theory? We can often compare scientists to detectives. Scientists look for patterns and connections in their observations in order to solve mysteries and to be able to explain how and why things are the way that they are. When scientists gather enough evidence to support their observations, they develop a theory. A theory is simply an explanation for an observation that is supported with evidence. The theory of plate tectonics. When scientists looked at the patterns between the location of volcanoes, earthquakes, and ridges and trenches, like the ones you saw in the mapping activity, they noticed two important things. First, they noticed that volcanoes and earthquakes were located along thin strips of land. So all of these places are where a high concentration of volcanoes and earthquakes are, which you would have noticed in the mapping activity. The second thing they noticed was that there are very large areas where no earthquakes and no volcanoes existed, or very little or very few earthquakes existed. Scientists observed that the location of these earthquakes and volcanoes was also along the ocean ridges. Using all the pieces of evidence that were discussed in the last slide, scientists developed a theory called the theory of plate tectonics, which states that the crust and upper mantle on the Earth is broken into large areas called plates, and these plates are constantly shifting and moving. What makes the plates move? Scientists aren't able to go into the layers of the Earth to see exactly why the plates move, but they have been able to use evidence again to create a theory or a reason why they think the plates move. This includes the characteristics of the mantle and convection. When we looked at the layers of the Earth, we found out that the mantle consisted of two different layers. The top layer is solid, and this is called the lithosphere, and the bottom layer is liquid. These characteristics help provide evidence to suggest how these plates move. Let's compare the mantle to a pot of boiling water. So in a pot of boiling water, what happens is, as we learned in the last unit, water is heated, it rises up, and it ends up pushing the cold water back down. This continues, and it creates what's called convection currents. Well, let's pretend that this water is the mantle instead. What's happening is, we know that in the layers of the Earth, heat's involved. Well, the mantle, the lower layer of the mantle, the liquid layer, is getting heated, and it's pushing up to the other part of the liquid mantle, and it's pushing the colder mantle down. This creates convection currents in the mantle. So now I've drawn two tectonic plates on top of the mantle. What happens when these convection currents continue to go into the circular motion is the motion of the currents forces the plates to move over or away from each other. This is one way that explains how and why the plates move the way that they do. It's simply due to the heat, characteristics of the mantle, and the convection currents in the mantle. Now what you need to do is view the interactive video to see how these convection currents actually occur and the movements of the plate actually occur.